In this video, let's take a look at how to use StatCrunch to perform a two-sample hypothesis test. And in particular, I want to look at a z-test for independent samples. So independent samples are two samples that the participants would not be related. For this example, we look at a medical researcher taking two samples and comparing the heart rates of smokers and non-smokers. So the people in each of these samples wouldn't be the same, right? We wouldn't have someone that's a smoker and a non-smoker. So these would be independent samples. Now, quick example of a dependent sample might be, would be two groups where basically the participants are the same. So for example, let's say I had a group of smokers and then I put them through a quit smoking class, and then 6 months later we do the sample of the same exact people. So because those would be, let's say paired data, we'd be looking at one person in the beginning and one person at the end. That would be dependent samples. So in this video, let's take a look at independent samples. And typically, within a textbook, one of the things that we would have to do is determine whether we're using a z-test or a t-test. And usually there's typically two determining factors. One being, do we know sigma? Do we know the population standard deviation? And if we do, we have the opportunity to use a z-test, standard normal variable, as our sampling distribution. And then usually the second question after that is, do we know the population is normal or the sample's large enough? In this textbook that I'm using, greater than or equal to 30. So we meet both of those conditions. We have samples that are greater than or equal to 30, and we know the population standard deviation sigma. So we're going to use a z-test here. Right, now depending on the textbook that you use, in particular, if the claim that we're testing is that the means are equal, we can write it in this manner. Some textbooks basically take the sample mean of sample 2, subtract it over, and set it equal to 0. You could say that sample mean 1 is less than sample mean 2, and again, some textbooks will take x bar 2, subtract it over, and it says the difference is negative, and then ditto for greater than says the difference is positive. So depending on the book you're using, might be how you, depends on how you write those hypotheses. Now in the verbiage of this problem, it says that the researcher suspects the pulse rate of smokers is higher than the pulse rate of non-smokers. Now the way that we have organized this info, smokers was our first sample, non-smokers was our second sample. So we're basically saying the first population, the smokers, is greater than the second population, right? The heartbeat, the pulse rate that we're talking about. So since this claim does not have equality, it's going to fall into the alternative. And the null then would be the complement of that, less than or equal to. So that would be the structure of our hypotheses at that point. So then we would want to determine, using the rejection region approach, what the critical values are, right? Where my rejection region is structured. So visually looking at this graph. So within the problem, we're told we have a critical level of 0.05, and because the alternative is a because it's a greater than, it is a right tail test. Now, if I'm doing this work by hand, right, typically what I would do is I would pull up my t-distribution. And on my table, I'm looking at a right tail for this problem. So I'm looking at one tail and I'm looking at 0.05. Because this is a z-statistic, it's a standard normal variable, I don't have degrees of freedom. So my table, I scroll all the way down and I look at the standardized test statistic. I look at the critical value of 1.645. Now, because my problem is right tail test, that's positive 1.645. If it happened to be a left tail test, I would use negative 1.645. So in this problem, it's right tail. There's my positive 1.645. Now, remember the approach using StatCrunch would be, if I bring StatCrunch up here, right, to find that critical value with StatCrunch, I'm going to click Stat, and I'm going to go to Calculator, and I'm going to choose the t-stat. Now I'm looking at a right tail, so I have the standard, and I'm going to choose right tail. And oh, wait a second, I'm not doing a t-stat, I'm doing a z-statistic. So I want to pick the calculator that is normal. My apologies there. So I'm the standard, I'm doing greater than. And remember, we're looking for the critical value here. We're looking for the z critical value. So we're going to leave that blank, and we want 0.05 in the right tail. So I compute, and there's my 1.645 that we received from the standard normal table. Right? So again, plotting that critical value of 1.645 in the right tail. Then we need to calculate our standardized test statistic. So again, conceptually, if our standardized test statistic falls in the rejection region, we reject the null. If it doesn't fall in the rejection region, we fail to reject the null. And because we can see my already pre-worked problem here, we can see what our standardized test statistic is. But again, as a reminder, here's what we would typically see as a formula in a textbook. We're going to find the difference of the sample means, and then we're going to subtract the difference of the population means. Then we're going to divide by the standard error. Now I have equal to 0 and the difference of the population means. Again, because typically in a textbook, when we look at our null hypothesis, what we're going to do is assume that this is an equal sign. We're going to assume that the population means are equivalent. So their difference would equal 0. Right? So I subtract, it would equal 0. So we're going to always assume there is no difference in the population mean. So in essence, my formula boils down to this. And the standard error for the two sample z statistic is this formula here. So basically, I'm going to take the variance of the first sample, divide by its sample size. I'm going to take the variance of the second sample, divide by its sample size. So I'm basically looking at, like, if you want to think of it this way, the total average variance, the total standard error between the two, right? I square root that answer. So based on the problem, I'm plugging in all of my information. So sample 1's mean was 87, sample 2 means was 84. So here's my 87 and my 84. My sample sizes were 100, and then these were the standard deviations. I need to square them to get the variance, right? And that's what we're doing here. So we plug all that in a calculator, we get 4.20. So how am I doing this in StatCrunch? All right, so in StatCrunch, I'm doing stat, and then again, I'm doing a z-statistic. Now in this case, I'm doing a 2 sample, and then I have the summary statistics. So you can see we're going to plug in the info for sample 1. We're going to plug in the info for sample 2, and we're going to select our hypotheses here. Let me pause the video and plug that in. All right, so again, looking at my problem, right, here's the summary statistics for sample 1. Here's the summary statistics for sample 2. And I'm plugging that in here to StatCrunch. And then in this case, our hypothesis was the alternative was a greater than. So in StatCrunch, I'm going to choose the greater than. And then I like to sketch the graph. I like to visualize our result. So on the first screen, we can see that we have our z statistic of 4.2, which is what we got by doing the work by hand. Now again, the interesting thing about StatCrunch is it'll give me the p-value. So I can compare the p-value to the alpha. So my p-value is 0.0001, and that is smaller than my alpha, so we reject the null. Right, now using the rejection region approach, let me go to the graph that we had drawn. Right, we can see the 4.2 right, critical value. Now with StatCrunch, they don't tell me, the 4.2 standardized test statistic, I can't speak today. They don't show me the critical value of 1.645 that we got on our graph. Right? They don't show me that. They're only giving me the p-value. They do calculate the standardized test statistic here, and they tell me the associated p-value. But in this problem, we were doing the rejection region. But at least we can compare to our standardized test statistic that we would have gotten by hand, and with the given p-value, we can make the decision. All right, so if you're doing a problem in an online homework system or for an instructor and you have to find the critical value, keep in mind that we can always use the table. Right? So to find this critical value, we can always use the table as we discussed here, and we can use StatCrunch and under the calculator to find that. Right, and that is an example of how to do a two sample independent sample z test.